Ladies and gentlemen, my name is Adria Mallol, and I will introduce our contribution to the Diagnosing COVID-19 Using Acoustics challenge. The goal of the challenge was to detect COVID-19 patients from the analysis of cough signals. In our system, we first computed the spectrogram representations of windowed versions of the input cough samples. These spectrograms are then fed into a convolutional neural network to extract deep learned representations from the input spectrograms. These representations are then transformed using a contextual attention mechanism, which goal is to learn to highlight the most important features for the task at hand. These transformed representations are finally fed into two stacked fully connected layers to perform the final classification. In this study, we added the perspective of gender in the automatic detection of COVID-19 patients. First, we trained a baseline model which didn't consider any gender information. Then we trained a gender-based model which included an encoded representation of the patient's gender as a feature before the final classification. Finally, we trained a gender-specific model which was trained using samples from patients of the same gender exclusively. We also compared the performance of two CNNs to perform this feature extraction. First, we trained a cough-specific CNN and then a pre-trained CNN. Specifically, in this case, we used a ResNet-18 to perform this feature extraction. In this slide, we summarize the main results that we have obtained from our experiments. Those two tables on the top contain the results obtained using the cough-specific CNN, while those on the bottom include the results obtained using the ResNet-18 CNN. Tables 1 and 3 report the results without this contextual attention mechanism, while tables 2 and 4 report the results obtained using the contextual attention mechanism presented in the slide before. In terms of performance, in terms of the area under the curve computed at 80% of sensitivity, we can observe that the best performance was obtained with a gender-specific model, specifically the one that used the ResNet-18 network for feature extraction with contextual attention. This model obtained a performance of slightly above 70% of AUC. Analyzing the results globally, what we observe is that the gender-based models obtained the best performances on 3 out of the 4 cases investigated. Therefore, it seems reasonable to state that gender impacts the detection of COVID-19 patients from the analysis of cough signals. Thank you for your attention.
Thank you, Adria. That's really... Okay, so I must have missed it in the first presentation. Could you say again what is the difference between a gender-based model and a gender-specific model?
Yes, so the gender-based is the version of the model that includes an encoded representation of the patient's gender as a feature, let's say. So it's a binary feature somehow. The gender-specific models are 2 separate models, one trained using patients of the same exclusive gender.
There's a question from the audience. Vikram asks, have you empirically or otherwise looked at what aspects of your features or spectral maps are particularly predictive of COVID-19 pathology for males versus females?
No, this is something that we would like to continue investigating. However, it's difficult because the dataset is clearly imbalanced in terms of gender. But I mean, this at least is a first starting direction, let's say, that we would like to continue investigating.
Sriram asks, have you tried performing gender classification from the cough? And is there any comparison to speech?
Not really. Actually, that would be a very interesting idea as a pre-processing system somehow. But in this case, since we had the gender information as a prior information for the challenge, we decided to use it already.
Laura is asking, how do you manage the gender imbalance in the data set?
We didn't consider, I mean, we didn't upsample the dataset or anything, so we just trained it with the data that we had. So, I mean, of course, this is one of the issues that we realized, that there were way more samples corresponding to the male gender than for the female gender.
So in the gender-specific model, that wouldn't matter because you've divided the data set, but for the gender-based model, then you have an imbalance between the number of male and female samples. Is that correct?
Yes, exactly. Although, of course, for the gender-specific as well, there is one of the models that was trained with way more samples than the other.
Yes, that makes sense. Thanks.
Thank you.